Humans have been modifying waterways for centuries. Reasons for modifications include for irrigation, for water abstraction, to provide safe navigation, or to provide power. However, many of our waterways are failing to meet good ecological status under the Water Framework Directive. And this is in part due to the dams and weirs which fragment the habitat. We're at Coltishall Mill, which is a historic mill site, which is now being used to generate renewable energy with an Archimedes screw. Also in place is a Denil fish pass, which is thought to be able to promote the passage of sea trout. It's a good example of how we can manage barriers to meet various needs. However, the problem is we don't often have the correct scientific understanding to fully reconnect our systems whilst accounting for the complex socio-economic conditions present at sites such as this.
The International Centre for Eco-Hydraulic Research at the University of Southampton is one of the lead partners in the European project called AMBER. AMBER stands for Adaptive Management of Barriers in European Rivers, and it involves 20 partners from 11 European countries, all tasked with the job of trying to reduce the impacts of river engineering on our aquatic environment. What we'll be doing particularly at Southampton is using state-of-the-art experimental infrastructure such as the large-scale flume facilities that we have to develop technology that we can use to mitigate for the environmental impacts of dams and weirs and other parts of the engineered environment that can be damaging to ecosystem services such as fisheries. One of the key challenges we face in Europe is not knowing just how many barriers we have. So one of the key tasks that we're going to conduct in the AMBER project is to develop an atlas of barriers to migratory fish throughout Europe. Much of the work we will be doing with our partners, particularly the UK partners, the University of Swansea and the University of Durham, really can be defined into three key areas. The first is understanding what are the main problems, what are the key challenges to improving environmental impact mitigation technologies such as fish passes. The other is to develop decision support tools that will enable us to better manage our river infrastructure. And the third one is to try and understand and quantify the socio-economic impediments to enable us to do this, such as stakeholder conflict.
Experimental work that will be undertaken at Southampton, which will feed into work package outcomes, will be undertaken in state-of-the-art facilities, such as this 23-metre long recirculating flume behind me. Such facilities allow us to pinpoint key behaviours that fish express in response to flow conditions common at river infrastructure. For example, here we see an eel rejecting an accelerating velocity gradient, a flow condition that often occurs at the entrance to downstream fish passes. Field experiments will also be undertaken to assess the impact of infrastructure on fluvial connectivity. Field techniques will involve electric fishing to assess the population dynamics in certain sections of the rivers, followed by tagging certain individuals and tracking their movements in situ. The data will be collected and used to parameterize computer models that will enable us to investigate the response of aquatic organisms to a range of situations. And this will help us more efficiently understand the impacts of barriers.
In collaboration with our network of AMBER partners across Europe, the University of Southampton is looking forward to working with other institutions in the UK, such as the University of Durham and the University of Swansea, to develop methods to better protect and manage our freshwater ecosystems to the benefit of generations to come.